Okay, so we're going to start on 10.3, which is hypothesis testing for a mean. Okay? Now, in one sense, this class is going to get super repetitive because the 7 steps I showed you yesterday we're going to do again today. The difference is we're going to be doing a different kind of data. Okay? So, I wonder if I should just start with an example. Okay? Now, actually, before I do that, hypothesis testing for a mean. Okay? I'm going to add one question to what we added yesterday. Okay? This is actually kind of part of step 3, but I'm going to tell it to you right now. Okay? When you're testing for a mean, the question you should ask yourself is, do I know the population standard deviation? Okay? I think I asked you this when we did the confidence intervals. So this is the same question. Now, what are the 2 possible answers you can say to this? You can either say yes, or you can say no. If you know the population standard deviation, what kind of a distribution is it?
Normal.
What? Normal distributions, which is the z distribution. If you answer no, what kind of a distribution is it?
T.
It's going to be a t. Okay? So, just as a reminder, the formula for the z is going to be x bar minus mu over sigma over the square root of n. I'll write this lower here. The formula for t is going to be x bar minus mu over s over the square root of n. So those are very similar formulas. Okay? Z versus t. Okay? So as we do some examples today, what I'm going to do is I'm going to go through the 7 steps just like I normally would. You're just going to add this question when you're picking step 3, picking your test statistic. Okay? So let's do an example here. The example says, the CDC, Centers for Disease Control, says mean number of cigarettes smoked per day by smokers is 18.1. We obtain a simple random sample of 40 retired smokers to see if they smoke less. The data results in 16.8 cigarettes per day and standard deviation of 4.7 cigarettes. Use alpha equals 0.10 to find out if retired smokers smoke less. Okay? All right. So what's the first of my 7 questions that you should ask yourself?
What's data for?
Is it quantitative, categorical, or regression? I heard quantitative over here because we've got a bunch of numbered values here, and we're testing for a mean, right? And by the way, I don't know if I should add this stuff in here. Maybe I'll just add this as part of step 3. Okay, so quantitative is correct. Okay. All right, now we're getting a little bit low on the board, so we'll try to go a little bit higher. Okay, question number 2 is, what'd you say? Find the null and the alternative hypothesis. Okay. Now, in order to find the null and the alternative hypothesis, you may want to go through and start labeling stuff. Okay. So let's go through the problem. CDC says the mean number of cigarettes smoked per day is 18.1. Something equals 18.1. What's the something? Mean, which is what letter?
Mu.
Mu. Why is it mu? Because you can't do X bar. It's kind of right, but what's a better reason? Population, because we assume that the Centers for Disease Control knows the population, right? Okay. So that's 18. When you're taking a simple random sample of 40 retired smokers, what's 40? N equals 40. See if they smoke less. Data results in 16.8 cigarettes per day. So something 16.8. P or X bar? I heard both. X bar, why X bar?
It's from like your sample.
Because it's a sample mean, right? Okay. So we're using a population mean, we're using a sample mean. And a standard deviation of 4.7, what equals 4.7? Oh, I heard S and I heard sigma. Which one's correct? Oh, should we vote? Okay, who says S? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Who says sigma? 1, 2, 3, 4, 5. Why did you say S? Eric. Because it's a sample. Why did you say sigma, Victor? Okay, so what's this data here? Is this based on the CDC? No, it's not. Okay, so S is the correct answer there. Okay, so that comes from your sample. Okay, now it doesn't say sample, but that's where it comes from. Okay, all right. So now my alpha is 0.10. That was clearly labeled. Okay, all right. So now I've got everything labeled here. What's my known, my alternative hypothesis? So let's pick on David. It must be your turn. What's the note on the alternative hypothesis? P equals 0.10. I thought my alpha was 0.10. So are we saying that smokers smoke just 10% of the time? No. Okay, so that can't be right. Okay. How about Sean? Can you pick and tell me what the null hypothesis is?
Yeah, same as mu, so mu equals 18.1.
Mu equals 18.1 because it's always about the population, and this is not a proportion. Okay, it's got to be a population mean. Okay, alternative hypothesis is what? Romero. What do you think the alternative is?
What are we trying to look for?
What are we trying to find out? We're trying to find out if retired smokers smoke less.
Mu is less than 18.
Mu is less than 18.1. Okay? All right. Now what? What's the next step? Step 3 is what? Pick your test statistic. Okay, now I gave you 14. I'm not going to do that. Here's what I'm going to ask you. Is this a Z? I'm going to take the main 4. A Z, a T, an F, or a chi-squared? And how do you know? I'd like you to at least break it down into those 4 types of categories.
T.
Okay, you pick T because why?
Because it's a sample, we're using S.
T because what?
It's a sample, we're using S.
Because we don't know our population standard deviation. Okay? So it's a T, that's correct. Now, what's my formula for T? Still on the board.
X bar minus mu.
T equals X bar minus mu over
S.
S over the square then. Since I've already labeled everything, this should be super easy to plug in, right? Okay. So, standard, can you plug all those numbers in for me? T equals, what's X bar?
X bar is 16.8.
16.8 minus mu, which is
the
18.1 over S, which is
4.7.
4.7 over the square root of 40. If I plug that in my calculator, hopefully I will get negative 1.749. Okay? Now, what do I do with that? What's the next step? Step 4 says find the p-value. Now, we need to talk about how do you find this with the chart and with the computer. Computer is actually going to be a little bit easier, but tomorrow's quiz is going to be with the chart. Why can I not minimize? Okay, so if I do it this way, oh, share my screen. Now, tables and formulas. Here's how you're going to do this with a chart. Now, unfortunately, you can't find the p-value with the t-chart directly. Okay? Now, remember, this is giving me the area to the right. Now, I probably ought to draw a picture. What's going on with my picture? What's the mean of the t distribution? It's 0, right? Standard t distribution. What value did I get? I got negative 1.749. I want to know if they smoke less, right? So do I want to shade the left side or the right side? I want less. I want to shade the left side. Okay, does that make sense? So I want this area here. Now, the cool thing about the t distribution is it's symmetric. So even though I have a negative value, I can still use this chart. The idea here is, what's my degrees of freedom? I didn't ever mention that. Degrees of freedom is 39. Okay, so as I go here, so I'm on 39 degrees of freedom, so right here. Okay, now, the idea here is I'm going to ignore the negative for a moment. I got negative 1.749. So as I go on 39 degrees of freedom here, okay, I'm going to figure out where does 1.749 fit in here. And it fits in between those two numbers there. Does that make sense? Okay. Now, as I go up here to the top, that tells me my p-value is between 0.05 and 0.025. That's the best you can do. My p-value is between 0.025 and 0.05. Okay, now, if you want to find the p-value exactly, you're going to need a computer. Okay, so, but this is, so if I'm doing this on the quiz tomorrow, this is the answer that I'm looking for. Now, if you want to do it with the computer, what command do you think you would use? T.dist. Okay, now, am I doing a left-tailed test, a right-tailed test, or a two-tailed test? I'm doing a left-tailed test. Okay, so that's going to be the first one. What's my x? It's going to be my t-score. I should put t there. Okay, so negative 1.749. My degrees of freedom? 39. Do I want the cumulative?
Yes.
Almost always you want to put true on these, except for the binomial distribution. So yes, you do want, yeah. So the default is true unless you're on the binomial, then you got to think about it. Okay? All right. So that gives me a score. So the actual p-value, I should have labeled that. P-value equals 0.044079. Okay? All right. So now step number 5 is what? Compare to alpha. What's my alpha in this case? 0.10. Okay, step number 6 says reject or not, because we never use the A word, right? Okay, So when I compare my p-value to my alpha, is my p-value low? Yes, it is. If my p-value is low, do I reject?
Yes.
Yes. If the p-value is low, you reject the null. Okay? So I believe here my null hypothesis says mu equals 18.1. I've rejected that. I do not believe the mean is really 18.1 anymore. So what's your conclusion?
Higher people smoke more.
Less. Why would they smoke less? Because they're only doing 16.8 versus 18.1. Okay? So the conclusion is there is evidence that retired smokers smoke less. Okay? It's because they don't have a job to worry about. They're not going to get up early in the morning. And they can sleep in. They can take away some of that stress. Okay? All right. Now, the only thing I want to add here, if this was a two-tailed test, what would be the only differences you would do? If it was a two-tailed test, I would need two tails, right? So let's pretend for a moment that this is a not equal to rather than a less than. Okay, so at this point, okay, would this p-value be correct? No, I would have to double that. The p-value would be between 0.05 and 0.10. Okay, it's still less than 0.10 though. Or I could double this. I could take that by times it by 2, and I get 0.088. Okay. So when you're doing a two-tailed test, you just double everything. You double your p-values. Okay. Even still, since it's less than 0.10, I would still reject the null, and I would have the same conclusion. Okay. All right. So the quiz tomorrow will be on 10.3. See y'all tomorrow.
So 10.3, are we gonna have to find, like, it's gonna be like all of them, all the steps? It's
All the
because like
steps.
10.2
Yeah, every
is just
step.
like
We're
Z,
just going to repeat this every time. So just do the 7 steps. Yeah, that's got to be due today. Okay.
So what is the difference between when we're using this formula for the Z-score for the test statistic and when we're using this one?
Okay, so this one's for proportions, this one's for means.
Okay.
So this one's categorical data, this one's quantitative.
Okay.
That's why we asked that question first.
Okay.
What kind
Because
of
if
data are you
it's,
using? Because
if it's
if it's
categorical,
categorical, you use this. If it's quantitative, you use that.
and in this case, we wouldn't care about the standard deviation. For the top one.
Well, this is the standard deviation. You figured it out yourself. So in fact, notice both of these divided by the square root of n. So the sigma is the square root of PQ. Okay. So
Awesome. Thank you.
So if I need help from try to see YouTube.
yeah, if you want to just show up at 7:30. Yeah. Okay.
like safe to.
Get walking, right? I had all my answers on it. Don't be late.
I don't want to go at all. As I,
2 days a week. Just do tell me right when I have all the questions.
it wasn't 30, so I expected you guys to already done.
Yeah, I have a lot of questions. There's also semantics. Okay, I'll think about it. If you want to stick around, but I might have to take out a few points because you saw all the answers. Okay.
This one, 29. I did all this right, and that right. So these values are right. Okay, what I did is I computed this and stored it in the calculator so that I was using exactly my calculation. And then I put this in and not all together.
Well, I mean, I don't know. Let me see what I would do. Okay, so if this is 6 divided by 15, oh, that is 0.4 exactly. 0.4, not 0.04.
Oh, it's 6 divided by 151.
Oh, 151. Oh, so 0.03975. Okay. So if I'm doing this, I'm using that number.
Right.
So this is 0.021, that's your null hypothesis.
Mhm.
So this is going to be this number minus 0.021. And then this is going to be the square root of this number times 1 minus that number divided by 151. Wait, what are we doing? Yeah, okay, equals this divided by that, which equals 1.17. So yeah, I'm getting a different number than you are.
Then what the heck did I do? I'm so I typed it in my calculator like 8 different times.
So here's how I would do it on the calculator. No,
It's the like that.
okay. Well, you don't want that to happen on the test.
I know, I have a bad
Okay,
calculator.
so you've got, what does it come? 6 divided by 151. So here's how I would do it. Okay, so here, so you press up arrow here.
And I do this. And then it stays in
Oh, that's weird. Okay, so how do I do that again?
Oh, yeah, you can store. And then
No, I want to recall it.
you want to recall it?
Yeah.
Oh, and you just do that.
Okay,
Wouldn't that
Minus
be minus 0.021?
0.021. Okay, so that gives me my number. Can I store that as B or something?
Yeah.
I'm going to say that as B. Okay. So now I'm going to take square root of, where's the square root here? Square root of, now I'm going to do A, how do I get A? Times 1 minus A, do that again. Divided by,
Wait. So you don't use 0.021 and 0.979 here?
oh, you're right. Yeah, see, I got confused. So can we change that to B? Yeah, that should be B, you're right. So that was B. Wait,
Wait, I don't
that's
think
not B.
Yeah, I don't think it's
No, you're right. So 0.021 times 1, okay, I got confused. 0.021 divided by 151. Okay, so now I want to take B divided by, call that C, I guess.
okay.
So now we're going to do B divided by C.
Wow. Oh my gosh. Well, okay, so let's go
That's
back here.
bizarre because I got 1.17.
You see? What am I doing wrong here? I don't know. And wait,
That's way off.
and my calculator was wrong. I've been using this for like,
Well, this is what you should have gotten. You should have gotten 1.17. Right? What does the answer say? I think I typed that in wrong. Oh, you know what?
it's 23, right?
You know what? I think I did do it wrong. But 021 times 1 minus 0.021. Yeah, that's correct. 1.605. I typed it wrong. So you're right. So that's correct.
But then, that, it says that the p-value is that, and go to the table
Okay.
to do it. With
This is a Z.
Yeah, I think so, right? That's me? Do I have that right?
Equals 1 minus that. 0.054.
So,
You got 1.61.
so,
So 1 minus that. 1 minus 0.9463. 0.0537.
so that's what I got. But then, if you look here, it says 0.0976. The book's just wrong?
I so
So I did it right.
You did-
I was freaking out last night because I was like, I literally, oh no, the other one, I went back to 9.1 to make sure I was in the confidence intervals right. And I like, went back and double checked my words. Like,
I'll have to figure out, send that one to me. If I have time today, I'll try to figure out how to let it, but yeah, everything you did is correct.
Okay.
Okay,
Thank you.
so that's weird.
I feel better about that.
Okay. Oh, did I not stop? I didn't stop recording.